Hello guys, welcome to my YouTube channel. Today we talk about one of the most important topic of mechanics of material, or sometimes it's called strength of material. In some country it's called mechanics of solid. The origin of mechanics of material dates back to the beginning of the 7th century when the Galileo Galilei performed experiment to study the effect of loads on rods and beams made of various materials. Through the year after many fundamental problems have been solved and it became necessary to use advanced mathematics to solve more complex problems. Today video we understand the basic of stress and strain. First question is what is a stress? So when the material is subjected to an external force, a resistance force is set up within the component and the internal resistance force per unit area acting on material or intensity of this force distributed over a given section is called stress at that point. So basically let's see, this is our component. P is a load and has a cross sectional area, square cross sectional area, has a width B and D. So here stress is equal to load divided by cross sectional area. So P divided by A for area, so P is equal to force acting on body in Newton, and A is equal to cross sectional area in meter square or mm square. So from this equation we can say that the unit of stress is expressed in Newton per meter square or in Pascal. Let's say some unit conversion for the basically used in mechanics of material. So 1 kilopascal equal to 10 raised to 3 Pascal or 10 raised to 3 Newton per meter square. 1 megapascal equal to 10 raised to 6 Pascal equal 10 raised to 6 Newton per meter square or 1 Newton per mm square. 1 gigapascal equal to 10 raised to 9 Pascal or 10 raised to 9 Newton per meter square. So in mechanics of material, basically generally we use these two units to express the stress or elasticity sometimes. Let's consider the case 1. So this is our body, has a load acting where this load is acting axially, not at some other location, but if it's act on a different location like this, then it's called eccentric loading. But in here it is a simple stress, so we just assume that it's acting only axially to the body in here. So the fiber of component tends to elongate due to this force acting on a body. So this, when the fiber of component tends to elongate, it's called tensile stress and is denoted by sigma t and always is greater than 0. And when the fiber of component tends to shorten due to the external force, is called compressive stress. And it always negative, sigma c less than 0. When force are transmitted from one part of the body to other, the stress developed in the parallel plane to the applied force is called the shear stress. So in shear stress, is always acted to parallel to the component. We know that fiber is made of, so one force is acting here and transmitted throughout the system. So one layer of is slide over the another layer, and shear stress act as parallel to the plane of intersect, and is always expressed on a mechanics of material like this way in a tau. And unit of the shear stress is the same, Newton per mm square or meter square. Now let's move on to the next topic. Is a strain. So strain is nothing but the percentage elongation produced in a component due to the external force. So let's say if the force P acting on the body, due to this force, the length of the component is changed by this much, and this is the original length delta L, and this is the actual length L. So from this case we can see that the strain is equal to change in length over original length. For this case it is a tensile strain. If the component tends to compress, then it is a compressive strain, which is denoted by compressive stress in negative L divided by L0. So this is the conventional or engineering strain. In here we divided the elongation to the original length, not the actual length. And same as in a shear strain. So here is our component, and it's moved due to the force acting on here, so it's move like that angle. This is the original length, and the deflection of this body is delta. So here shear strain is equal to change in of length divided by original length. So the deflection of body is like delta L, this much, and so divided by this original length. So that's it for today's guys, and thank you very much to watching this video.